Completing the square part 2. In this video, you'll learn to complete the square of a quadratic expression of the form ax squared plus bx plus c, where a is not 1. So to complete the square means to add a constant term to a quadratic expression to form a perfect square trinomial. If a quadratic is a perfect square, then we can write ax squared plus bx plus c in the form of kx plus m squared, where a is equal to k squared, b is equal to 2 times k times m, and c is equal to m squared. So we'll try to make sense of these equations and relationships by looking at an example. So we'll take the expression 4x plus 1 squared. So we know that 4 is k and 1 is m. And we'll try to put it in standard form of ax squared plus bx plus c. We know that a is equal to k squared. So that means that we can replace a with 4 squared since we know k is 4, and 4 squared will give us 16. Now let's look at the relationship of b. b is equal to 2 times k times m. So we can put this in for b, and we change k to 4 and m to 1 since we already know those values. This will simplify to 8. Now let's look at the relationship for c. c is equal to m squared, so we'll put 1 squared in for c, which simplifies to 1. Here's another one we'll try. This time k is 5, and m is negative 2. So when we put it in standard form, we'll look at a first. We know that a is k squared, so we can replace this with 5 squared, which simplifies to 25. Now we'll look at b, so we'll multiply 2 times k times m, and in our case we'll replace k with 5 and m with negative 2. This simplifies to negative 20. Now let's look at c. c is equal to m squared, so we'll square negative 2, which gives us positive 4. Here's one last example, and this one has a variable instead of a number for the constant, so we'll see how that changes things. This time k is 3 and m is n. So if we want to put it in standard form, then we'll replace a with k squared, which is 3 squared in our example, which simplifies to 9. b is replaced by 2 times 3 times n, which simplifies to 6n. And c is equal to n squared. Now let's look at some different examples. 4x squared plus 12x plus 9 is a perfect square because it can be rewritten as 2x plus 3 squared. The equation 4x squared plus 8x plus 25 is not a perfect square, but how can we make it one? We can see that we got 4x squared by squaring the 2x in parentheses. And we can see that we got the constant of 9 by squaring the 3 in the parentheses. The value of b, which is 12, is taken by multiplying 2 times 3 and then doubling it. So if we take the equation that's not a perfect square, we can see that the ends are already perfect squares. So we can write this as 2x plus 5 squared. But this tells us that the middle term should be 2 times 5, or 20, but we have 8x instead of 20x. So if we wanted to make this a perfect square, we would have to add 12 more x's to make it 20. Here's another example where we'll find the value of c to make each expression in the left column a perfect square. Then we'll write the expression in factored form. We'll put our relationships up so this can help us find the k, m, and c value. In our first example, we see that a is 100, and since a is equal to k squared, then k must have been 10 to give us 100. And if we look at 80, we'll use our relationship of b that says b is equal to 2 times k times m, and b will be replaced with 80. And we know k now is 10, so we'll put that into our equation. This simplifies to 20m. So to find m, we'll just divide 80 by the 20 that we have. So we have a value of m of 4. c is equal to m squared, so 4 times 4 will give us 16. Now we can use these letters to write it in factored form of 10x plus 4 squared. Now let's look at the next one where our a value is 36. Since a is equal to k squared, then k must be 6. Now let's look at the value of b. So we'll use our relationship, and it says negative 60 is equal to 2 times k times m. We know k now is 6, and this simplifies to 12 when we multiply. We can divide the negative 60 by 12 to find m, and we'll get a value of negative 5. Now to find c, we're going to square m, so we'll get positive 25. In factored form, this gives us 6x minus 5 squared. Now let's look at the last one. We see that a is 25, and since a is equal to k squared, then k must have been 5. We'll put our b value of 40 into our relationship. We know that k is 5 now. When we simplify this, we get 10. So we can divide the 40 by 10 to see that m is equal to 4. To find c, we're going to square m, so this gives us 16. In factored form, we have 5x plus 4 squared. Let's go back to our notes with the equation and the relationships. And we're going to see if we can work backwards. So if we're given an equation in standard form, we want to put it in factored form. The first thing we want to do is make sure the equation is in the form ax squared plus bx equals c. So we'll move that constant of 5 to the right side by subtracting it. This gives us 3x squared plus 8x equals negative 5. Now we want to make sure that the value of a is a perfect square. Right now we have 3, which is not a perfect square, but we can make it a perfect square by multiplying it by itself. So we'll multiply the entire equation by 3. And this gives us 9x squared plus 24x equals negative 15. Now we're going to find the value that makes it a perfect square, so we're going to find c. We'll need to start with our first relationship of a first. We know a is 9 in our example, so that means that k must have been 3, since 3 squared will give us a 9. Now we'll take our b relationship and put 24 in for b. We also know that k is now 3. This simplifies to 6m, so we can divide the 24 by 6 to find that m is equal to 4. Now we can find c by squaring m. So we'll get c is equal to 4 squared, or 16. So now we're going to add this value of 16 to the equation. We'll add this to both sides, and this gives us 9x squared plus 24x plus 16 is equal to 1. In factored form, it would be equivalent to 3x minus 4 squared. So now we'll move this up so we can solve it by using square roots. We'll take the square root of each side, and we get 3x plus 4 is equal to positive and negative 1. So we'll set up both of our equations, one equal to positive 1 and one equal to negative 1. We'll start by subtracting 4 from both sides. This gives us 3x is equal to negative 3. Now we'll divide both sides by 3, and we get x is equal to negative 1. On the next one, we'll start by subtracting 4 again, and this gives us 3x is equal to negative 5. We'll divide both sides by 3, and we get x is equal to negative 5/3. Let's try another one like this, where we have 5x squared plus 17x plus 6 equals 0. We'll start by subtracting that 6 so that we can get the constant on the right side. This gives us 5x squared plus 17x equals negative 6. Now we need our a term to be a perfect square, and 5 is not a perfect square. But we can multiply it by itself to make it a perfect square, so we'll multiply the entire equation by 5. And this gives us 25x squared plus 85x equals negative 30. Now we'll use our relationships to find the value of c that we need to add to both sides to make it a perfect square. So we'll start with a equals k squared. We know a is 25, so k must have been 5, since 5 squared gives us 25. Our relationship for b says that it's equal to 2 times k times m. And we know that b is 85, and k is 5. This simplifies to 10m, so if we divide the 85 by 10, we'll get that m is equal to 8.5. To find c, we just need to square m. So we'll take 8.5 and square it, which gives us 72.25. So this is the value that will make it a perfect square. So we'll add this to both sides of our equation. This gives us 25x squared plus 85x plus 72.25 is equal to 42.25. In factored form, it will give us 5x plus 8.5 squared equals 42.25. Now we'll move this up so we can solve it. We'll take the square root of each side, which gives us 5x plus 8.5 equals negative and positive 6.5. So now if we needed to solve for x, we would set up our two equations and continue solving, but this is good for now for this example. In our last example, we're going to solve both equations by completing the square. If we look at our first equation of 4x squared plus 4x equals 3, the constant is already on the right side, so we don't have to do that step. Our a value of 4 is actually already a perfect square as well, so we don't have to multiply this by anything. So we can start by finding the c value that we need to add to both sides to make it a perfect square. We know that k is going to be 2. Since a is equal to k squared, then k must have been 2 to give us 4. We know that b is equal to 2 times k times m, and b is equal to 4 in our equation, and k is equal to 2. Simplifying it gives us 4m, so that must mean that m was 1. To find c, we just need to square m, so this will also give us 1. Now we'll add 1 to both sides of the equation to make it a perfect square. This gives us 4x squared plus 4x plus 1 equals 4. And in factored form, it will be 2x plus 1 squared equals 4. So now we can start solving by taking the square root of each side. This gives us 2x plus 1 is equal to positive and negative 2. So we'll set up both equations where 2x plus 1 equals positive 2 and then negative 2. We'll start by subtracting 1 from each side. So this gives us 2x is equal to 1. Now we'll divide both sides by 2, so we get that x is equal to 0.5. Now we'll subtract 1 on the other equation, and this gives us 2x is equal to negative 3. We'll divide by 2, so our second solution is negative 1.5. Now let's look at our other equation. First, we need to move that constant to the right side. So we'll do that by subtracting 10 from each side. Now we want to make sure that a is a perfect square. Right now it's 6, and 6 is not a perfect square. So we'll multiply everything by that 6 to make it a perfect square of 36. This gives us 36x squared plus 114x equals negative 60. Now we'll find the value of c that we'll add to make it a perfect square. We know that k must have been 6 since 6 squared gives us a 36 value of a that we have. And b is equal to 2 times k times m. b is equal to 114 in our example, and we just determined that k was 6. This simplifies to 12m, so if we divide 114 by 12, we'll get a value for m of 9.5. To find c, we're going to square the 9.5, and this gives us 90.25. So we'll add this to both sides of our equation. Now we have 36x squared plus 114x plus 90.25 is equal to 30.25. In factored form, it's equivalent to 6x plus 9.5 squared. So we'll start solving this by taking the square root of each side, and this gives us 6x plus 9.5 is equal to positive and negative 5.5. So we'll set up both of our equations, and we'll start by subtracting 9.5 from each side. So we have 6x is equal to 4. Now we'll divide both sides by 6. So we get x is equal to 2/3. On the next equation, we'll start by subtracting negative 9.5 again. This time we get 6x is equal to negative 14.5. We'll divide both sides by 6, and we get our final solution of x is equal to negative 2.5. Now let's summarize what we've learned. If ax squared plus bx plus c is a perfect square, then it can be rewritten as kx plus m squared. If a is not 1, we need to make it a perfect square by multiplying the equation by the current a value. We can determine which constant to add by looking at the k, m, and c values of the equation.